Okay, 13.3.3, can I get a slope? Okay, slope functions, you have calculated various rates of change in this course. Beginning with average rates of change, you move to instantaneous. You have studied how these rates change related to position and velocity and connections between the two. So we're going to use our knowledge of rates of change to write slope functions for graphs we created in the previous lesson. So talk about those patterns we noticed, right? And so let's just move straight into 123 here. So we consider the function f of x equals 2x. Okay, what is the slope for 2x at x equals 1? Okay, so here's the deal, right? How do we create that instantaneous, right? It's the limit as h approaches 0, right, of f of x plus h minus f of x all over h. Okay, so let's do that, right? So this is 2x plus 2h minus 2x all over h. So that is 2h over h cancels, and we get 2 is our slope. So what is our slope at 1? It's 2. What is our slope at 3? It's 2. What is our slope at 100? It's 2. In calculus, a slope function is denoted as f prime of x, okay, which is the slope function of this problem. Okay, so looking at 124, right? The slope function for 2x was easily determined because that function's linear, right? So linear becomes a constant. We talked about that in the last lesson. So now let's consider x squared. Okay, so g of x equals x squared, right? So it says make a prediction. What is the slope function, or g prime of x squared, right? We should know that it's going to be linear. We kind of talked about that in the last problem. But so let's calculate the average rate of change from 2 to 2 plus h, right? So so let's look here. So this is going to be f of 2 plus h. So it's going to be 2 plus h squared minus 2 squared all over h. So then let's do the math here. 4 plus 4h plus h squared minus 4 all over h. 4's cancel. I have 4h plus h squared over h. Factor out an h. We have 4 plus h over h, and h cancels, right? As h approaches 0, I'm going to get a 4 there, right? So what's the average rate of change from 2 to 2 plus h, right? It's 4 plus h, right? But then as h approaches 0, right, we get a value of 4. Okay, what does this tell you about the graph of g of x at 2? Its slope is 4. Okay, or 2 squared is 4, right? Okay, so let's just look at this, right? D, now write an expression for the average rate of change of g of x from x to x plus h. So here we go, right? So we have x plus h squared minus x squared all over h, right? And we're taking a limit as h approaches 0. Okay, so looking here, we're going to go x squared plus 2xh plus h squared minus x squared over h. X squareds are going to cancel. I have 2xh plus h squared all over h. I'm going to factor out an h, so I have 2x plus h over h. Those h's are going to cancel. I will now have the limit as h approaches 0 of 2x plus h, which is going to give me 2x. 2x is my slope function, so g prime of x equals 2x. Okay, again, g of x was x squared, so it becomes linear. We talked about that, right? So then evaluate g prime of 2, right? So all we'd have to do then is plug in a 2, and we get that 4 that we just got. Okay? Cool, let's do this again for x cubed. Okay, so x cubed, make a prediction, right? It should be some squared. It's going to go down. Okay, let's do this, right? The limit as h approaches 0 of x plus h cubed minus x cubed all over h. So again, cubed, right? So that you can do binomial expansion theorem. You can write it out. I'll actually write it out for you guys just so you can see it. Doing this 3 times, right? X times x is x squared plus xh plus xh plus h squared. Okay, do this again. X cubed plus x squared h plus x squared h plus xh squared. I'm out of room. Plus x squared h plus xh squared plus xh squared plus h cubed. Okay. So here we go. Clean this up. X cubed plus 1, 2, 3 x squared h plus 1, 2, 3 xh squared plus h cubed minus x cubed all over h. X cubes cancel. Factor out an h. It's going to leave me 3x squared plus 3xh plus h squared all over h. H is going to cancel. And then the limit as h approaches 0 of the following is going to be 3x squared. That is my slope function. Right? And then use your f prime or your slope function to predict. X at 1, that would be 3. Right? Again, you're just plugging in, right? F prime of x of 3x squared. We just plug in 1. You're going to get 3. Plug in 3. 3 squared is 9 times 3 is 27. Plug in 100, right? 100 squared, right, is 10,000 times 3, 30,000, right? Makes it a lot easier. Okay, so you can do this again, right? You can evaluate your limit, right? This one's going to be a little harder. We just did x cubed, but now we got minus 2x, right? And see what happens when there's multiple terms there. So let's do this. Okay, so the limit as h approaches 0 of x plus h cubed minus 2x plus h plus 1 minus x cubed minus 2x plus 1. Sorry, I'm out of room there. Plus 1 all over h. Okay, we just did this, so I'm not going to multiply that back out for you, right? X cubed plus 3x squared h plus 3xh squared plus h cubed minus 2x minus 2h plus 1 minus x cubed plus 2x minus 1. Okay, it cancels. 1 and 1. Positive 2x, negative 2x. Negative 3x, positive 3x. Okay, so what's left? 3x squared h plus 3xh squared plus h cubed minus 2h all over h. Factor out an h. 3x squared plus 3xh plus h squared minus 2. H's cancel. Then the limit was as h approaches 0, right? So that gets rid of this. Sorry, that gets rid of this and this. So what am I left with? 3x squared minus 2. That is my prime function. Okay. Pretty cool there. Pretty cool there how that works. A lot of work there, right? But that is 13.3.3.